Python is a great programming language to learn for anyone in the data profession. Nowadays, many companies ask for Python skills when they advertise for data jobs. If you are an Excel person, learning Python could be a great way to enhance your resume and find interesting and exciting job opportunities. In this video, let's understand how to use Python with plenty of examples. By the end of this video, you will learn how to create Python programs to solve practical problems. We will also be doing 3 projects. 2 of them are mini projects and 1 of them is a big project. In our big project, you will learn how to create a simple expense tracker app using Python that can take the expenses that you are encountering and then save them to a CSV file with date and timestamp. You will also learn how to use Python concepts such as variables, if-then condition, for and while loops, lists and list comprehensions, how to work with various modules within Python, and how to think about solving problems using all of these ideas. You can download the source code files for this using the link in the video description. But for best results, I highly recommend that you follow along and recreate the examples on your own in your computer. That way you will learn and understand and appreciate Python better. We've got a lot of work to do. Let's get in. Oh yeah, I almost forgot this. In this video, I'm not really explaining how to install Python or how to set up Python on your computer. I'm assuming that you already have it there. But if you do not have Python, then use the links in the video description for downloading Python and installing it on your computer. In the video, I'm using Visual Studio Code, which is a free software from Microsoft that you can download and use it to build various types of coding systems, not just Python. So again, link for that is in the video description. Let's move on. Let's start our Python journey with a very simple Hello World program. Here I'm using VS Code to build and view my Python code. So I'll go to File, New File, and then from here I'm just going to say Python as my language and then start typing the code. We can use the print statement within Python, print function really, to print a message. So I'm going to just say hello viewers. This is our first Python program. And Control S to save this. I already have a getting started folder, so I'll just say hello.py and then save this program. Now that this is saved, we can just run it. And this is just gonna print the message here. Hello viewers, this is our first Python program. Awesome. Now let's just enhance this by just instead of saying viewers, we'll first ask the question, what is your name? And then it'll say, hello, Mr. John or Bob or Cynthia or whatever may be the name. So the first thing that we will do is get their name. This is where the input function comes in. You can say input, what is your name? Now this input function is going to collect some value, that is the name of the person, and then we need to bring that value back and then use it inside the print statement. So we'll have to have a variable to store the name. So name is equal to input of what is your name, and then in the next line we will just say instead of hello viewers, we want to now print that name. So where the word viewer is, that's where I want the name to appear. So we'll close this, and in between we'll just use the plus to bring that name. Let's test this out. So here it's asking me what is your name. Notice that at this point the program has stopped. It'll wait for your input. So I'll just say Chandoo, and then it'll say hello Chandoo, this is our first Python program. Notice that what is your name question mark is where that stops, and then my name comes up here. If you want to be a little bit pretty, you can add an extra space here, and that will be how that value comes up. So we'll just try this again. What is your name? Now there is a bit of space. I can type Chandoo, and then it will come up with that. While this is good, you may want to have the name itself appear with first letter in capitals or something like that. Because name is captured into a text value, we can use some special functions on top of text values to deal with these kind of conversions. So let's try the name dot title. This is a type of function that is available on the text values. The correct way to represent that is string values. They're not called text values within programming world, they're called strings. So name.title will return a different type of name with first letter capitalized. So let's try this again. What is your name? My name is Chandoo. And here now it says, hello Chandoo, this is our first program. So this is how Python really works. It's a very, very simple language to get started. You can use print and input to kind of get the input and print outputs. Most of the time when you are building code to do real world stuff, these sort of things are not used that much. There are many other things that we will use. So now that we understand how the Python language system works, let's go and understand some of the theory and then come back for more coding. Whenever learning something new, mind map is a great way to understand it. So I'm going to draw a Python mind map so that we can understand how this language works. So let's start in the middle with Python. The first concept that you will understand in the languages is what words are available. So within Python, we refer to this concept as keywords. We can kind of imagine the print example that we did just now like a keyword, but to be correct, it's not a keyword. The print is actually a function. On the other hand, keywords are the special words that the language uses to denote certain things. So for example, if I want to write a if condition to test between two possible outcomes, then we will use the if keyword in the Python language. There are many keywords in the Python language, and we will introduce these as we make progress. Another key concept within the programming languages is variables. A variable refers to the idea that from time to time you need to store some values in computer's memory and then refer back to that. So for example, within the previous code that we have written, we collected user's name and then we printed hello message to them. So the name is stored in the variable name and then printed back. So that is a variable. And whenever you have variable, there is obviously some sort of data type associated with it. So for example, that variable itself could be a number, it could be some text value, or it could be a true false value, which in programming world is called Boolean. And then there could be other types of variables that are more complicated. So I'm just going to say complex here, and you will see what I mean by this when we make progress into our Python learning journey. So we have keywords and then we have variables. Another thing that you have within programming languages is concepts. Concepts are how you get things done. So for example, if I want to test between two conditions, let's say I ask for user for their name and then their age, and based on the age, I want to do one of the two outcomes. So for example, if they're under 40, I want to print one message. If they're over 40, I want to print a different message. So this is when we need to use a concept of if condition to achieve that. So this is where we have various concepts. The two main concepts are your conditions and loops. As we evolve our programming understanding, you will realize that there are other concepts as well. So for example, you could have functions, which are individual blocks of code that run whenever they're called. So think of your overall program as a big block of code. It can have internally smaller blocks of code that will do specific things. The print function that we used just now is a classic example of a function. Another idea within programming languages like Python is the operator. Operators are symbols or special words. So some of the operators could be keywords also that can do certain things. A simple operator is the plus operator. You can use it to add two values. So if I have two numbers, 2 and 3, I can use the plus operator to combine them to generate a new value, which is 5. So there are many types of operators. So naturally you have operators further divided into arithmetic operators, comparison operators. So for example, plus is my arithmetic operator, but if I want to check if one value is greater than or less than another value, I would use the comparison operator, such as less than, greater than, etc. We will play with these things in our examples very soon. Time for a new pen because we are going to talk about some more things. Another concept within Python is libraries. Within this particular video, I'm not going to get into too much of libraries, but this is something that you will very soon realize when you start building your Python knowledge. Many times if you want to do a certain activity, it doesn't make sense for you to write all the code yourself. You may want to borrow someone else's code that already does certain things. So for example, the print, we are just calling the print function and the print function is printing the message. We are not really worried about what sort of monitor the user is using, what display driver they have, and all sorts of things. So internally, we are kind of relying on a library that will do that task. Likewise, if you are doing some machine learning or advanced data analysis or making visuals or automating stuff, it makes sense to borrow a library. Python has many libraries, and you can use them on demand to achieve certain things. Another concept that you commonly hear within Python and many other such languages is objects and classes. In a way, this is loosely linked to our complex data type idea that I introduced earlier. So what an object refers to is, an object is literally anything. So for example, that toy here is an object. If I want to build such a toy within Python, I would obviously have toy related details, but it might also have some functionalities. You may realize or not, but this toy has a functionality as well. It can laugh. So if I press the button here, it will laugh. Anyhow, that is one object, but you have another object like pen or paper or screen or whatever. So when you want to build things around that, you may want to create an object and then use that. If I have to draw a parallel between Excel and Python here, we could think of a spreadsheet as an object within Excel and use that object to do things on it. Like for example, I could go to the spreadsheet, a specific cell, and type a value there. So that's where I'm acting on that object. Same thing happens within Python. Within Python, it has many objects that you can readily use, as well as you can use the libraries to introduce new types of objects into your system. Class is basically a class of object, and an object is an instance of a class. Again, these are technical words, but essentially what it means is this is a pen, but it belongs to the pens class. So imagine you have a pens class, and then this red pen is one of the pens. But you could also have other pens, and all of these are part of the pens class. So you would create a pens class, and then you just create one pen at a time depending on what you need. So that's at a very high level what an object and a class is. A simple type of an object that we commonly use within Python is a list object. So list is something that we will definitely try out in this tutorial. A list is nothing but a collection of values. In other programming languages or systems, you would have arrays. Python has lists. A simple way to think about list is like a range within Excel. You have a range of cells, each cell containing one value. A list is, I think, similar to that. It is a list of values, and you could then use the list to store a collection of items. So for example, if I want to go to a web page and download all the images, I can build a list of all the images from that web page and then act on them, maybe save all of them on my computer or compress them. So if I take an object like a list, the list itself will have basically two things. It will have some properties, and then it will also have some methods or functions. Again, these are technical words, so it doesn't make sense to elaborate them here. We will do that as part of the coursework. So that is Python mind map. Now let's go back to the computer so that we can write some Python code and learn more about the language. Let's understand a little bit more about the variables. For the purpose of this, let's explore the number variables. So I want to take two variables. Number one is 23 and number 2 is 47. Notice that within Python, you don't really have to use any other special statement like dim or var or anything. You just start typing the variable is equal to and then assign a value, and automatically Python will create a variable for you. So now both of these numbers are there within my Python program. I want to print their total as a message. So we'll say print, and then I just want to say num1 plus num2. So num1 plus num2, and then here we will just say plus. We'll try this one out first, but before we even run this, I want to just make sure that this part of the code no longer runs. So only this is the one that we are testing out and seeing the result. But I just don't want to delete it because I want to keep it for future. So this is where you can use the commenting to kind of comment out the code that you don't want to use anymore. You can use hash to comment out a line of code, and whenever Python reads this line, it simply ignores it. Now let's test this one out and then see what happens. I get an error. Let's see what this error reads. Trace back most recent call list. Again, just as many other computer systems, Python also has these errors, and sometimes these errors can be intimidating or confusing. But if you get used to the programming, then it will become easier for you to understand. Basically, the error that we get is type error must be str, not int. So here, the print function is expecting you to give it only string values, whereas number1 plus number2 is a number or integer, so it's not working. This is where typecasting comes into picture. Typecasting refers to the concept of taking data of one type and then converting it into another type. So we can use the str function to take the result of these two values and then turn that into a string. Let's run this. Now the total is coming up correctly, as total of two numbers is 70. Just as you have numbers and text values, there are many other different types. So for example, if I have the value as 23.2 and then 47, I'll get the result as 70.2. At this point, Python has automatically converted the total as well into a floating point number or a decimal number, and then applied string conversion on top of that to get you this result. Let's use our understanding of all these concepts and then build a simple program to check user's age and then print a message based on that. So I'll make a new file, new file. Now when you are building Python programs, it is usually a good practice to keep all your related code together, and depending on the coding environment that you're using, you can do this in multiple ways. For example, here in VS Code, I have already built a getting started folder and my hello.py is here. So I can create a new file within this. So we'll just say agecheck.py, and then I can build my age checking code here. This way, all the workbooks or all the Python files that I'm generating will all sit in the same folder in my computer. The purpose of age check program is to ask user for their name and age, and then print a message that tells them how many more years are left before they become 50. So we need to have two inputs. Name is equal to input of what is your name, and then age is an input of, now name itself is fine because when you collect the input, it will be a text value, so name goes into that. But any input that you enter will always come out as a text value. Whereas for age, it needs to be a number for us to process it. So I'm gonna add a typecasting function of int in the beginning and end of the name input. So age input, so that it will say whatever is the input that I collect, it will then convert that into an integer. So we got name and age. Now, the idea that we want to do is we want to print a message that says, hello name, you will be 50 years old in this many years. So we can calculate a third variable. This would be years to 50, and this can be 50 minus age. And then we can just print a message, print hello plus name. You will be 50 in str of years to 50 plus years. Let's read this. Hello name, you will be 50 in str years to 50 years. Let's test this one out. What is your name? Chandoo. How old are you? I'm 41. Hello Chandoo, you will be 50 in 9 years. Awesome. Now let's test this one out for someone else. So we'll put James. And how old is James? 72. Hello James, you will be 50 in negative 22 years. Now this sentence doesn't make any sense. This is because James is already 50 and beyond. So maybe if someone is already 50, then we want to say you were 50 22 years ago. So here is where, depending on the value of years to 50, if it's positive, then one message. If it's negative, then another message needs to come. So this is where the if condition comes into picture. Let's write this one. If years to 50 is greater than 0, then I want to run this part of the code. To run a part of the code when the if condition is true, you just have to indent that piece of code inside. So Python uses this indentation method, whereas if you have done programming in any other language like VBA or Java or C or any other language, they've all used different notations to kind of block the code. So for example here, if years to 50 greater than 0, greater than is the operator there to check the condition, and this is the one. And anything else that you don't want to run inside that if condition, you just print it outside. So for example, I can just say print by. Let's test this code out. What is your name? James. How old are you? 72. Let's start with 46 first. Hello James, you will be 50 in 4 years, and then I'll get a bye message as well. This is good. Now let's try this again. James, 62. It'll simply say bye. It's not even gonna print any message. This is because we haven't told Python what to do if the condition is not true. We have only said if this value is greater than 0, then print this message. So to do the else part, we can have else, and then we can have another print message here. This will be hello. Again, you can just type all of this. I'm gonna be lazy and then copy this whole thing. And you were 50. Now here it should be negative of the years to 50. So str of negative of that. Ego. So this indentation thing is somewhat confusing, at least for me, because I have started learning programming with languages such as C, and then later on Java, and then PHP. And finally, now I'm doing coding within Python. So because I come from a different background, normally in all those programming languages, we use a different notation like curly brackets to kind of indent the code that belongs to a block. So for example, this block of code here is my if block, and this is else block. So to keep things simple, you would always have like a curly bracket or something else in those languages. Whereas within Python, the intention is specified with the indentation, and this can be a little confusing when you get started, but later on it becomes quite natural. So let's run this. James, 62. Hello James, you are 50 12 years ago. This statement looks a little confusing, so you may want to change this. So it could say, hello James, 12 years ago you were 50. That way, the numbers are not together in the same place and confusing. Also, there is no space here. So I'm just gonna add that space, hello, and then use the name.title on both of these. James, 62. Hello James, you're 50, 12 years ago, bye. So this is how the if condition within Python works. Using if condition is a great way to test different conditions and then run different parts of your code to branch out the logic. In many business situations, if conditions become like second nature for programming, because there is always different things that need to happen based on various values that you're reading. In this exercise, let's build a very simple expense calculator using Python. I have added a new file to my folder, expensecalc.py, and here the purpose of expense calculator is it will ask the user for a series of inputs where you can just type the expenditures, And when you finish typing, if you just type 0 to stop the input, at that point, it's going to tell you what the total expenditure is. So think of this like a very, very simple calculator. This will introduce the concept of looping. So if I want to collect some input values from my user about their expenses, I can have, for example, exp1 as input. What is the expense? And then we can kind of repeat this line. So I'm just going to copy paste this few times. And this can collect up to 4 inputs because there's 4 values. So exp2, exp3, exp4. And then I can print the overall total by taking the sum of all these 4 numbers. But this approach is kind of silly. It only works up to 4. And if I want to maybe enter 20 or 30, then I will have to repeat this. On top, we need to know upfront how many times we have to collect. So normally within programming languages, we use a concept of loop. A loop is a set of instructions, for example, this line itself, that runs any number of times. So we'll understand the concept with a very simple loop first, and then we will build the expense calculator. So let's just print up to 10 numbers. To do this, we can just say a variable and then set this to 1. And then we can type while our variable I is under 10, we just print the words I. And once we finish printing, we need to move the I to next point. So I will become I plus 1. So when you run this, this is going to repeat this part of instruction and that part of instruction up until the I value becomes 10. Let's run this. And here is our loop. It runs up to 10 values. Because we have put up less than or equal to 10, it's going to run for 10 times. If I want to do it for 100, I can just do it like this. And let's just remove equal to there to see what happens. So this is going to print up to 99 all the way from 1. What happens if you don't increment? Then what happens is I value will never change. So it will remain at 1. And because 1 is always less than 100, this loop keeps running. This thing is called an infinite loop. It just keeps running. 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 All right, you get the point. To break an infinite loop, you can just go to the console and then press Ctrl+C in Windows to break the program and return to the prompt. Many times in the programming situations, you might accidentally get into an infinite loop situation, and this can be both funny and frustrating depending on what you're doing. Now let's just build our expense calculator. So we'll have a variable called exp, and then we'll just initially set this to -1. The idea here is the program will prompt you what is the expenditure, and then you can just repeatedly enter expenditures. When you finish doing, you just type 0 to stop, and at that point it'll tell you the total. So and then we will also declare a variable called total expenditure, which is 0. And then we will type while exp not equal to 0. Notice that this symbol not equal to gives me a red underlining. When you point on this, it tells me that operator less than greater than is not supported in Python 3. Use exclamation equal to instead. So that is the not equal to operator within Python. In some other programming languages, we use less than greater than, but within Python, this is how you check for not equal to condition. So while expenditure is not equal to 0, as long as that condition is true, we want to get the expenditure. So expenditure would be input, what is the expense? And then you may want to just say type 0 to stop. Whatever input is taken, we are going to convert that into an integer. And then as you're doing this, we also want to add up the expenditure to total. So total is equal to total plus exp. So whatever is the total up to that point, we're just going to add the expenditure to it. When we start the program, because total is already 0, it's going to just say 0 plus whatever is the first expenditure, and then it just keeps going into that. And then here we'll just say print your total expenditure is, and then say plus str of total. Let's test this out. So here, what is the expenditure? $12, $18, $10, and then 0. So 12 plus 18 plus 10 is 40, and we will get the answer. This is how you normally use loops. Let's take this to the next level Apart from your total expenditure, I also want to print two more stats. One is what is the maximum expenditure that I incurred and what is the minimum expenditure that I incurred. So to do this, we also need two more variables. Let's just declare them here. Max exp is 0, min exp is 0. As we add total, we also need to figure out what is the max expenditure. So max expenditure would be if exp is greater than max exp, then max exp becomes exp. This might seem a bit confusing, but if you understand what is going on, at each step we gather the expenditure and then we check if that expenditure that you have typed in is already greater than the maximum expenditure so far. If so, then we make that new expenditure the maximum expenditure. Let's just stop with this for now. We will come back to the minimum logic in a minute. Then we can just at the outside, when you finish running the loop, you would have a value in the max expenditure which is equal to the maximum of all the values typed. So here the maximum you spent is str of max exp. So 12, 18, 10, 0. Your total expenditure is 40. Your maximum spent, the maximum you spent is 18. We can have a similar condition for the minimum expenditure as well. I leave that to you as homework. So add that here and then also print another statement that tells me what is the minimum you spent along with the totals. While our expense calculator program works very well, it has one limitation. It doesn't have any record of the actual expenses entered. We can only see the total expenditure and maximum as well as minimum if you have done that part. What if I want to see all the expenses entered as output on the screen, or maybe save that to a file? This is where, as we gather the input, we need to actually store them in a collection of expenses. This is perfect example for using a list. So let's use that. I will do this in a new file. So we'll call this as expensecalc2.py. And in this file, we will follow the same structure. We'll declare a variable called expenses and set it to an empty list. In Python, lists are denoted with square brackets like this. So for example, you could have a list of expenses like 12, 18, 10, 19, 23, 10. So that is a list of expenses. And if I print this list, exp, I will see my expenses printed out as a list. Let's say at the later point in time, I just want to see how many total expenses are there. I can, for example, use the len function on the list to count how many values are there. So we can say print len of exp, and then if you want, you can also add something else. So total items in the exp list, and do it like this, and it will give you total items in the exp list 6. Notice that here, instead of using the plus operator, we are passing two different parameters to the print function. This is another way, and in this technique, you don't need to do the typecasting. You can pass different parameters and all of them can work together. So the len function takes any item and then it tells you how many values are there in that item. It is a generic function and it will just tell you number of items in a container. So again, these words might seem confusing, but if you want to understand this a bit more, for example, I can say len of Python. And what that will do is it will tell you how many letters are there within the word Python. Coincidentally, that is also 6. Apart from len, we can also do several other things on the lists. If you type a list name like exp and then press dot, depending on the development environment that you're using, it might show you all the things that you can do on the list. So for example, I can append a value to the list. I can clear, copy, count, extend, index, etc. So for example, let's append another expenditure of 25. And then let's just print the expenditure list after that. So we are printing it twice, once before and once after. Here I'm just going to say after exp and then before exp. So before it's 12, 18, 10, 19, 23, 10, and after that it becomes this. So using the append method, I can add items to my list based on what the user is entering. So let's build our second version of expense calculator. We'll declare a variable called exp, which is equal to empty list. And then we will also have another variable. This one is stopped and this is false. So initially we have not stopped. We want to continue gathering the input, and then we will make this true if the user's input is 0. So while not stopped, while not a false initially, so that will be true while true, then we want to get the input. E is equal to input of, and then we will just do a typecasting here, integer of that, and then exp dot append E. Now we don't want to add the input if E is 0. So here we will just say if E is not equal to 0, then we want to append, else we want to just set stop to true. Means we have done our part, we no longer need to do it. Notice that this true shows up in green color, that yellow color underline. You have to use capital T here, and then outside our while loop we will just say print exp. This is just gonna print our expenditure. Let's just test this program first, and then we will add the next feature. So it will just say what is the expenditure: 12, 18, 10, 19, 0. So as soon as I type 0, I get out of the loop, and then I have my 4 expenditures captured in a nice list. Notice that the order of items in the list is as per the order in which you recorded. Now that the items are in a list, we can do some additional operations on top of the list, like total expenditure. So for example, I can just say print total expenses and then use a function like sum of exp to sum them up. 12, 18, 10, 19, 0. So this is going to add up those 4 values, and then it'll just say 59. Just as we have sum, we also have min and max. So for example, max expense is max 12, 18, 10, 19, 25, 0. So it's going to add up all the expenditures to 84, and then maximum is 25 out of that. So different ways to solve the problem. Our original approach was to just add these things up because we have not even considered the possibility of storing all the values. But sometimes you may want to keep track of the values for a list in your memory, or maybe you want to save them to a file or something. So in that case, the list is a great option for you to keep track of all the things and then use them later on. We will play a little bit more with loops as well as lists in the subsequent parts of this video. Lists are a great way to store your data. So let's spend some more time understanding lists. Along the way, you will also be able to learn how to use the for loop. We can declare a list using a variable. So for example, L is equal to, and then square brackets, and then type the values. So you can have 1, 2, 3, 7, 4, 5. That is a list of values. And as you have seen, we can, for example, print the length of L. That'll just tell me how many items are there in the L, and we'll get the answer as 6 items. Alternatively, you can also just print L, and that'll just show you the values of the list. Because lists is part of the built-in functionality of Python, it gives you access to several functions on top of lists that can be used to manipulate or manage the list. So for example, if you say L dot, you will see all the functions that are available for us. We can count how many items are there. We can extend a list. So using extend, I can just add more item to the list. So here I'm going to add 3 more items, 3, 9, 12. Now our list is going to have these extra items added at the end. Let's print L again and run this program. So initially we have 1, 2, 3, 7, 4, 5. And now these 3 values are added at the end. So in our earlier program, we used append to add a single value, whereas if you want to add a whole bunch of values, you would use the extend method. I highly recommend that you spend a little bit of time playing a little more with these methods within lists. But an interesting concept within lists is we normally don't declare lists like this. We either generate them or we bring them in from some other data sets. So let's talk about how to generate the lists. So we can have a variable called L and just set it to square brackets. And then let's say I want to load up all the numbers from 1 to 100 in this list. There are a couple of ways to do it. Assuming you don't know anything else and your Python knowledge is just where you are as of this video, the only way to do this is to use the while loop. So we could have a number starting with 1 and then say while number is less than or equal to 100, and we just say L dot append number and then number equal to number plus 1. And then outside I can just print my list. Let's just run this. So here we get our list all the way from 1 to 100 generated. Now once it reaches 100, our while loop terminates and then we will get the list. While this method is good, it is kind of not very interesting. So this is where let's introduce a few more techniques. So another option for us is instead of using all of this, I can use a for loop. So we can say for num in range 100, L dot append num. Notice that here we are now using a completely different word here, range. Range generates a range of values. We can kind of think of that as a list in itself. So you could think range 100 would be a list of 100 numbers. Technically, that's not even true. You can read the message here. It generates a special type of an object called range object, which would have those values when iterated. So then you can append there. In this method, we don't even need to increment the number because it kind of goes through within the for loop. If you have done a little bit of VBA programming, you kind of recognize this syntax for something in a collection of items. So range is basically a collection of items. Let's run this. And again, we will get the answer. Notice that here our range starts from 0, goes up to 99. So when you say range of 100, it's going to get you 100 numbers starting from 0. So it will stop all the way at 99. This is all right, but certain cases you may want to go from 1 to 100. Then you will have to adjust the parameters or change the logic inside the loop. So for example, you could simply say num plus 1 inside the loop and get the same result. So this is another method. Both these methods, the while loop as well as the for loop method, require you to run the process, that is this little instruction, 100 times. So this is where Python really shines because it also offers other ways to generate the lists. We can use a special technique called list comprehension, using which I can generate this entire list without even having to loop through. You could think of this as internally the computer will do the job, but from a coding perspective, you don't have to do it. Because computer does it internally, it will do it in a faster and more optimized fashion. So let's talk about list comprehension here. I'm just going to comment out our for loop. So instead of declaring an empty list at the beginning, we can simply say list is equal to num for num in range 100. So this is the standard syntax for your list comprehension. This is the most confusing part of the Python programming language for me when I'm learning the language. This is because we do not use this kind of a structure in many other traditional languages. So because that is how I learned, for me this was the hard bit. But once I got used to it, I'm more appreciative of how easy it is for me to work with. Let's see the result first and then we will talk more about this. So again, same result as the for loop. You go from 0 to 100 in the list. So we generate the list in one go like this. Usually you just have any made up variable. So here I'm having the word num as my variable, and then the for condition, which kind of goes through that and then generates all the possible values of that. So you can think of this two lines somehow shrunk into that one line there. So for num for num in range 100. We can use list comprehensions for many powerful things. So for example, I have L, I can have all the even numbers as a separate list. So in this, I will simply say num for num in range 100, and here instead of just saying num, I'll multiply number with 2. So the first parameter itself is another operation on the number. So what this will do is it'll just make up first 100 even numbers. So we will have this. I forgot to print the even numbers. We'll just say print even numbers. So we will have two lists. The first one goes from 0 to 99, and the second one is basically double of that. Every number is multiplied. List comprehensions are an amazing and awesomely powerful way to manage and generate data, and even use this for many powerful applications. So this is basically one of the game-changing things within Python, but it can be slightly confusing depending on what your background is and how much of prior technical computing programming you have done. But once you get used to it, it becomes quite easy to understand. So I again recommend you to spend a little bit more time learning about these techniques. Now let's talk about how to access specific items of the list. Let's say I don't want to print my entire list. I want to just print the 7th item in the list. So this is where I can use, for the purpose of this, let's just deal with even numbers. I want to print the 7th even number. I can just open square brackets and then say 7. This is because my even numbers is a list. So here I'm asking what is the 7th item in the even numbers. It'll come up with the answer as 14. Let's double check this by printing the numbers itself. So here, this is my 14. That's what 14 is. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8. So 14 is actually the 8th item in the list, but it says that's the 7th item. This is because within Python, the indexing or the counting starts from 0. So when I really say 7, I'm asking for the 8th item because the very first item is the 0th item. So if I say 0 here, you'll see the very first item, which would be 0. So here is my answer. So this is one of the things that you need to keep in mind when you're working with lists or any other data types where you have a collection of items and you're accessing a specific item. Things always start with 0. So you have 0 and then you have items like this. One of the cool things within Python is you can use positive numbers to access a specific item, or you can use a negative item. So for example, I can say, what is the list -1? And that's going to give me the very last item. So let's just see this, 198. So if I just say list and then -1, I'll get the very last item. Likewise, if I say -3, I'll get the third item from the last. So 194. We can also use the slicing operator or this operator to access a specific portion of the list. So let's say I want to see what items are there in my even numbers list, starting with the index 1 and ending at index 3. So this is how you write this. And what this will do is it'll give you the items from index 1 to index 3. The normal human way of thinking about this is second item to fourth item. So second and third item you will get. So here you will see the answer as 2 and 4. Those are the second and third item. That's what we will see here. We can take this further, and if I exclude any part of this expression, so for example, if I just take out that, then I'll get everything up to the third index, but not the third index itself. So for example, this one is going to give you 0, 2, and 4. That's because 0 is my 0th index, first index, and second index. So I'm not going to get the third one, but I'll stop there. And you can do it the other way around. So if I just do it like this, I'll get everything from third index onwards. So we'll get all the numbers to the end. So this is how you can slice a list just to access a specific portion of the list and then use that. There are many other complicated functionalities available depending on lists or other types of data that you might work with in your data analysis situations. So again, it makes sense to spend a little bit time playing with these things and thinking about practical problems and how to solve them, and then learning about those scenarios. Now that we understood list comprehension and how to work with lists, let's use these concepts to build a simple multiplication table as a project. This is like a mini project. We are also going to do another big project toward the end of this video. So we will I'm going to add a new file. I'll call this as multiplication table.py. And here the idea is we will ask the user or the person who is using this program enter a number, and then they can type any number. Based on the number they typed, we want to print the multiplication table of that number up to 20. So we will have a num as input, which would be integer of input, what multiplication table you want. So this is going to capture the user input into the number value. And now we just want to generate a multiplication table. We'll keep things simple first, but then we will add layers of complexity. So I'll call this as mx multiplication table is equal to a list. The list will have 20 values, each for one multiple. So we can just use any variable here. I'm just going to say x for x in range 20. Initially, this is just going to contain 0 to 19 values. And then what we want is we want to take and multiply that with number. So we'll just say x times number, and that will basically take the user input and then multiply that with all the 20 values to generate all the outputs here. So this is my initial list. Let's just print this, print mx. So let's run this. What is the multiplication table you want? Let's start with 7. I'll get the multiplication table of 7. It starts from 0 to 133. This is kind of counterintuitive. So what I'm going to do is I'm just going to say x plus 1 times number here. So even though we are working in the range of 20, every number we just add 1. So it goes from 7, 14 all the way up to 140. Let's run this again. 7. So we'll get this. While this is all right, this is kind of a very lame type of a multiplication table. Nobody reads multiplication tables like this. So this is when you want to think a little bit about how do I present this information. One way to think about this is maybe I want to have my multiplication table in this format. So 1 times 7 is equal to 7, 2 times 7 is equal to 14. Now that's how I want my multiplication table to look like. We kind of have all the numbers there. The 7 is in my num input. 1 and 2 are my x plus 1. And the 7 and 14 are my x plus 1 times number. So all the values are there. We just need to kind of generate a representation like this. So one way to think about this is I'm going to declare a new variable mx2. This is where we will generate the table using list comprehension. This should introduce you to some more ideas of working with these things. So a list comprehension where I want to have 1 times 2 times like that. So we would have x for x in range 20. So this is our base comprehension. And then for each x, what we want to do is then we will want to have x times 7 printed there. So we're going to start by having a string representation of x. For example, if I leave it here, what I will get is 20 numbers, but each is represented as a string. So let's just see what the mx2 looks like. We'll just delete these bits, Control F5. This will still ask for input, but our output list is basically 20 numbers, but each is represented as a string. So you can see with this single quotes, that's really what it is. So here we will use that idea and then kind of take this forward. So strx And then I want to have an x added times plus strnem. So what this will do is 0 x and then whatever my input is, 0 times 7. Then again we will add within double quotes equal to. So we did use double quotes sometimes and single quotes sometimes. You can use either of them within Python. So then is equal to and then plus str of x times nem. This might all seem a bit confusing, but let's just run this and then see whether this works, and then I will explain it to you in a minute. So 7, I'll get a bunch of strings. 0 times 7 is 0, 1 times 7 is 7, 19 times 7 is 133. We can kind of add that plus 1 here and plus 1 there, and that'll make the multiplication table but in a list. So if I run this now, let's just try for 19, one of the hardest tables that I had to remember as a kid, and we will get all the 19 table values as text values in a list. So you can see how powerful the list comprehension concept itself is, using which we are able to generate the entire table with just one line of code. One annoying aspect of this is how often we have to use the typecasting function str like this. So there is another shortcut that you normally use within Python, and these are f function or f expressions. So we will rewrite the mx2 with f. So here I'm gonna just say f, and then within single quotes we will just write the whole thing, and then that'll kind of work. So initially I want x plus 1, so x plus 1 as my expression, and then we will just say x, then number is equal to x plus 1 times number. And what this kind of f does is it's gonna, wherever there is a curly bracket, it will run that as an actual Python code, and then wherever there is no curly brackets, it will just print the text value. So you can use f to quickly generate a long string of values for both your print statements or list comprehensions or whatever may be the case, for x in range 20. Let's test this one out. We will just print mx3 now. Again 19, we'll get our 19 table beautifully returned to us here. So you can use any of the techniques to do the job, and this is where most programming languages, when you are learning, the key thing to keep in mind is there can be infinite number of ways to your solution from your problem. And initially, as you are learning, there is no right or wrong way. You just have to pick the way that is most comfortable to you and then go with that. But as you evolve your programming knowledge, you may have some preferences as to using certain approach versus others. So that is a good mindset to have. Don't think too much in your early stages of learning about is this the best piece of code that I can write, or there is something else that I could do. Though that is all irrelevant. Focus more on learning the language, becoming comfortable, and being able to think in the language. Those are valuable skills to have. Later on, you will develop your own style of coding that works best for you. So I hope you found this mini project multiplication table a little bit insightful and useful for some of the other things that we will cover later on. Let's bring all of our Python understanding in one place with a Python project. The purpose of this project is really simple. We want to create an expense tracker app using Python. So our expense tracker app would do these things. Number one, whenever we run this tracker program, it will ask you for a list of expenditures, and it will keep collecting the inputs until you type 0. So it will collect expenses. The second thing that it will do is all the expenses that you type in, it will save them to a comma separated values file, CSV file. When the data is being saved to the CSV file, it will also timestamp the data. So for example, if I type in some data today, it will have today's date and the expense for each of the expenses that I typed. And then when I run it tomorrow, it will add the tomorrow's date and then again those expenditures. So this is what our app will do. It's a very, very simple app, but whenever you run, you can track your expenses and the system will automatically add the dates. By building this app, you will also learn how to use the concept of loops and lists, but also understand how to work with external files such as CSV files and how to use the libraries within Python to deal with this challenge. This is going to be a great exercise for you to enhance and solidify your Python understanding. So let's go ahead. We'll start by adding a new file. I'm gonna name this as my tracker project.py. While we have all the key ingredients for this tracker, which is how to collect the input and how to build the list, we do need the assistance of two other things. Number one is how do I put this data into a CSV or any other file? And number two is how do I get the current date? This is where we will now have to rely on the libraries within Python. To import a library, you can use the from keyword and then bring any library. So the library that we have is Datetime. So from Datetime, import date. This is gonna bring a class named date from the Datetime library or the Datetime module within Python into your working file. Again, these words or the concept might seem a little technical, but once you use them, it all makes sense. So now that I have access to the date class, I can use that to ask the question, what is the current date? And then get the answer from Python. So let's see what date has, date dot, and then it has many functions using which we can kind of do operations on the date values. You can think of this as the date functions within Excel. There is many things, but the today function seems appropriate for what we need. As of the date when I type the expenditure, I want to timestamp it with the current today's date. So date of today is going to give me a date value that is equivalent to today. Let's just print this to see what this looks like. Print of that, and I will get the answer as 21st of May 2022. Notice the format here, it's year, month, and then date. Instead of printing this, we can also store it in a variable. So for example, we can have a variable called dt, and that is equal to that. And then I can use that dt inside my loop to add it to the data. The next thing that we also need is we need a mechanism to deal with the CSV files. So this is where Python already has a package that we can readily use. It's the import CSV. So there are two ways to bring things into Python. If you want to bring a specific item out of a big module, Datetime is a big module that has many things in it. Then we use the from Datetime import syntax where I'm saying within this module, just bring only that element to me. Whereas if I want to bring the whole thing, the whole module, I just use the import CSV. This way I get to have all the items that are part of the CSV mechanism as part of my Python code. I can straight away use any of those things. Our first task is, even before we achieve the overall project, to understand how the CSV thing really works. So all we want to do is make a new CSV file and then print the current date into that file and then close it. So this is the first task that we will do. Once we get comfortable with that process, then we will kind of build our expense tracker around it so that every expense that you type will go and sit into the CSV file. So we'll have a file name. Let's just call this as test.csv. That's the file name. And we want to create this file and then just print the current date. Now, if you just type the file name, then it will go and sit in the current folder where you're operating. So here I'm operating in my getting started folder. When I run this, the test file will be created within this folder on both my VS Code as well as the physical folder on my computer. The next step is to open the file and then add data. So this is where when you are opening the file within Windows or Linux or Unix or whatever system maybe you're using, you can open the file for different purposes. You can open the file to read it, write it, or read-write it, or append data to it. Again, these are how computers really work. Sometimes you just want to view a file. You have no intention of editing the file, whereas some other times you may want to edit the file. So you need to tell your intentions to computer when you're opening the file. In this case, since we need to write data to the test.csv file, we need to open it in the writing mode. So we will use the with statement and then use open. Open is a function that is now available to us. And then we will say open file name in write mode as a file. So we have opened the file, and then within this file, we will now put our data. To put the data, we need to use a CSV writer. So CSV writer is equal to csv.writer file. So if you observe this particular syntax here, essentially what we are using is we have already imported the CSV class, and it has a writer functionality that can take a file that you have opened, and then it will figure out the internal mechanism of how to create the CSV file. And all we will do is a CSV writer dot write row. So because it's a CSV writer, you can either write a row or multiple rows. We'll just write a single row, which is equal to the date value. So we'll just say dt, and then we'll just close the file. Let's just run this program. And then we will see the result, and then I'll come back and explain any missing bits. So it didn't run. You can see that while the test.csv now appeared here, it is blank. Let's just see what the error message is. You can see here iterable expected, not datetime.date. So write row is expecting a value that it can go through and add, whereas dt is not seems to be the correct one. So maybe if I do something to the date, like convert that into a string or something, that might work. We'll try str of dt because this is the only one that we know so far, and run it. No error messages. So whatever date that I have, it is converted to a string, and that string write row is able to write that. Let's just see this. It is converted, but you notice that this format is kind of meaningless. So it's taken each of those letters in my date 2022-03-21, and then each letter is comma separated, including the hyphens in the date. So this is a meaningless format, and it doesn't really work for us. I'm gonna close this and I'll come back here. Let's introduce a different function that can actually take the date and format it. So we can use the dt.strftime. So strftime is a special function. What it can do is it can convert the date time values into a specific string. So for example, here if I say %d, %m, %y, I'm gonna get a date in this format. If you have used the Excel function text or the VBA function format, you can think of this as that, but only for date time values. So I'm just going to print this so we can kind of get a sense of what that looks like. This is how my date now gets converted, 21st of May 2022. So maybe if I print this, that's going to work. If it's not working, then we will have to do something else. But now that the date is converted like this, instead of printing, I will update date with date of strftime. So initially we start with today, and then we will reset the date to the formatted version of that. And here I'm just going to say dt and then run it. No error. Let's just see. It is still taking the string, and because it is a string, it is adding commas everywhere. This is kind of like not working as desired. So the correct way to do this is we take the date, and if we pass the date as a list like this, then each item in the list will become one value of the CSV. So if I run this now, I'll get a single value in the CSV. There is no comma. But if I, for example, have date comma 8, just another value there, it could be 8, it could be 72, it doesn't matter. Then I would have the date and then 8. So this is really the key here. Now that we have the current date and a comma with any value that can be added, that value needs to be the expenditure value. So let's go ahead and build the whole mechanism now. We have a mechanism to write the date and any number in a list format like this. All we want to do is just do this in a loop as long as the value that I type is not 0. So we will set up the rest of the information here. We'll have exp, which is a blank list. And then we have a variable stopped, and this is equal to false. So we start with not stopped scenario, and then we will say while not stopped, we need all of this thing internally in the loop. So while not stopped, we want to get the input. The input will be taken into xp is equal to integer of input. So it'll take the input, convert that into an integer, and then store that into xp. And then we will just check if xp is not 0. So if xp is equal to 0, now when you're checking if something is equal to 0, you can't just use a single equal to, you'll have to use double equal to. Earlier we used it not equal to, now we are going to do the reverse of this. If it is 0, then I want to stop my program. So stopped is true, else I want to do all of this thing. So this is where the order of these things is important, because here I'm kind of both explaining and doing it. Sometimes we don't really think about it, but usually when you do these kind of projects, you first think ahead about the steps and then do it. So we don't need to open this file every time. We just open it once, but every time we write. So this open statement with open as file needs to be outside the while loop. So I'll close, put that there, and then we will bring all of these things inside that. So once we open the file, then while not stopped, we keep collecting the inputs. And then if the input is not equal to 0, then we stop. Else we then want to write the value. And this step is also not needed here. This can be done once outside the loop. So we'll set the CSV writer, and then at this point, we just have to write the value. The initial part is date, and then where it says 8, it should be xp. Oh, my caps lock is on. So we write a list that has two values, date and xp, and it's basically going to write both values with a comma in the middle. And that's pretty much it. So then this thing will continue running while the not stopped stuff is happening. We also need to append the xp to my list so that I can show all the expenses that I gathered today as a list. So we will just say exp, that's the list name here, dot append xp. So notice the way this is going on. We open the file, and then we set up a CSV writer, and then we start our loop, which will keep running all of these things, where it will just ask a question. If I type 0, then I'll be stopped. Otherwise, I'll continue. And whatever value I typed, I will write that along with current date into the file, and then I will append that value to the list. So once this whole process is finished, then I'm just going to close my file. That means I'm done writing the file, and then the file is closed. I can now print your expenses today are, and then comma exp. So I'll print that list there. And if I want, I can also your total is, and I can just say sum of exp. Let's just test this, and then we will come back and see if there is anything else need to happen. So it'll ask a question, what is the expense? Type 0 to stop, 12, 18, 10, 19, 25, 34, 0. So it shows me the full list. Total expenses are 118. And if I go here, I will get the expenses. While it does have all the values, 12, 18, 10, 19, 25, 34, I see a disturbing trend of some blank lines in the middle. This can be a problem. So we need to tell how to add the blank lines when we are opening the file. So here, when you open the file name, you have additional options as well. So here you have a new line option too. So every time when we add a row, it's adding another new line. We don't need to do that. So here I'm going to tell new line is essentially blank. There is no new line. So with this approach, what it will do is it will not add any new line. So let's run this now. 12, 18, 10, 19, 0. So these are my expenses. If I go to my CSV, it looks pretty good. Everything is fine. But you might notice another problem, which is every time you run the program, it rewrites the values. So the original values are no longer there, they're gone. This is a problem. One way to fix this is you can open the file in append mode. So instead of W, if you put A there, then the original contents are retained there, and then every time you run, it will keep adding to this file. So if I run this now, I'll ask the question, what is the expense? So 19, 10, 23, 0. So we added three more expenses to be honest. And if I go here, I will see those 3 added at the end. Because I'm running all this program today, the date is not going to change. If you want, you can actually add a date timestamp, but for something like expense tracking, you don't need that level of precision. But if you want, you can definitely try that. But whenever in future you're watching and you run this program, you will see that date as of your system and the data added there. So this is how we can build a very, very simple expense tracker. While this is all good, it is a nuisance to run this tracker project from the VS Code or your Python IDE every time you want to keep track of expenses. So here is how you can actually launch this and keep track of expenses without even using any of the Visual Studio kind of environment. Just go to command prompt and navigate to the folder where your file is. So this is my folder where I have saved my tracker project, and type py space tracker project.py. So this is automatically, it will launch Python and then run this program for you. So it says, what is the expense? Type 0 to stop. We've been typing 12, 18, 10 for a while. So I'm going to try different numbers: 78, 90, 34, 54, 0. I'll get my total expenses today are this, and your total is 256. So if you want, you can check the result in the CSV file here, or alternatively, you can go to your Windows Explorer. So I'm just going to bring up my folder here, and this is my test.csv file. It has all the expenses. I can double click on it to open this in Microsoft Excel and just see that the values are nicely coming up in both columns. I have got my date column here and my expenditure column here, and I can use some sort of analysis within Excel to summarize this by day or whatever. Another way to analyze this data is we can use more Python programs to look at the data and then ask questions or summarize the expenditure by day or keep track of the trend or do some further analysis within Python. That is all out of scope for this video, but you can take those up as a challenge. Now that you have finished the Python tutorial, you might be thinking, what is next for me? How do I take my learning ahead? Here are some suggestions for you. Number 1, practice the ideas. There is a lot of interesting and powerful concepts I have introduced in this hour-long video. So I highly recommend that you set aside time and apply all of these ideas in various parts of your life. And the second suggestion that I have for you is do a project. Pick a project from your hobbies or your personal life or your work life and try to do that using Python. For example, both my kids are learning how to do programming with Python, and my son recently has been doing a Python project on his own. I asked him, what are you doing? And he told me that he is using Python to kind of keep track and analyze the statistics of some of the cards in the Clash Royale game. It's a mobile game that he does play quite often. So he's using the dictionaries in Python to kind of maintain the data and then use that to understand the cards and analyze them. So yeah, pick whatever you fancy and use Python to do a project. That way you get to put all the skills that you're learning in one place and practice them in a more in-depth and meaningful fashion. The third recommendation I have for you is read a Python book. I highly recommend checking out the Python Crash Course book by Eric Mathis. We, as in all four of us in our family, have read this book and thoroughly enjoyed this book and used it to learn Python quite deeply and well in a span of couple of months. So yeah, please check that book out. I have got a link for that in the video description below. The fourth recommendation that I have for you when it comes to learning Python, or in fact when it comes to learning anything a little bit technical, is take it slow and give it time. Do not feel pressurized or rushed and think that, if I learn for a week or 3 hours or 10 days, I will learn Python. Python, or any other programming language for that matter, does take its own sweet little time. To give you a simple example, I have been programming for about 26 years in my life, and even then, when I started learning Python earlier this year, it took me good 3 months to really understand where everything is and feel comfortable with the language. So give it time and do not rush through the process. Take it slow. And the fifth recommendation I have for you is consider going for a course. If you have got a little bit of money and extra time, then I highly recommend going for a course on Python. That way you get to have a concentrated learning effort. So if you're looking for some inspiration or ideas, I recommend checking out the courses by Code Basics or Programming with Mosh, or any of the courses that are available on online places such as Skillshare or Udemy. I've got some of the links in the video description. Again, check them out and go for them if you want. And the final recommendation I have for you is enjoy the journey. Anything when you are learning, if you are having fun and if you are really happy with the process, then you will learn it better, you will remember it better, and you will cherish the whole experience. Some of my favorite learning experiences back from school or college days are when I was really engaged and happy with the whole process. So enjoy the process, and if you feel like one way of learning Python is a little too clumsy or depressing for you, go and choose another way of learning it. Whatever works for you, go with that. I wish you all the best with your Python journey. I'll catch you somewhere else. Bye-bye.